In Space lecture notes. Ancient Egyptians, Babylonians, Chinese, lots of different cultures were the first to study astronomy, which is basically the study of the moon, stars, and other objects in space. Two words you need to differentiate between are rotation and revolution. Rotation means an object spinning on its axis, like you spinning a basketball on your finger, a tire spinning around its axle, and a planet spinning on an axis. A figure skater spinning in place on the ice. All of these are examples of rotation. For the Earth, it takes 24 hours, and it causes our cycle of day and night. Revolution, on the other hand, is when the object moves around another object in space. So the Earth moving around the sun, carousel horses moving around the center of the ride, you moving around the middle of a track. All of those would be considered revolution. For the Earth, it takes 365.25 days to get all the way around to back to where it started, around the sun, and this causes our year. Now, because of those extra quarter days, every 4 years we've accumulated an extra day, so we fix that by creating a leap year, and we put an extra day into the February calendar and makes up for that extra time. Seasons on Earth are caused by three main things. It has to do with how directly or indirectly the sun hits the Earth and where that happens. The fact that the Earth has a tilted axis, and the fact that the Earth moves around the sun. All of these combine to create the seasons. Now, the sun hits the Earth directly or indirectly, depending on the curvature of the planet. So the sunlight coming in and hitting the center of the sphere right here is hitting it at a direct angle. This is about a 90-degree angle. Further up or down, north or south of the equator, the sunlight that comes in, you'll notice, hits the curvature of the Earth at a different angle, a lower angle than 90 degrees. And of course, up near the poles, the light coming in is striking the Earth at a much more oblique angle, not nearly 90 degrees, more like 10 or 20 degrees. These different angles cause different temperatures. You know, if you face a campfire and you put your hands out flat to the campfire, they will feel hotter than if you were to keep them horizontal to the ground. So the angle at which sunlight hits the Earth changes the temperature of the Earth pretty drastically. Plus, the sunlight hitting the Earth on the curvature part, more up near the poles, is spread out over a greater distance, and so therefore it feels cooler. The Earth has a tilted axis. It's about 23.5 degrees tilted from vertical, and this is going to help cause the seasons. So what ends up happening is, notice the tilt does not change. It's still tilted in this particular picture to the right. In the real world, the North Pole is always tilted towards the North Star out in space. So this axis here is tilted towards the sun. This axis, the northern axis here, is tilted away from the sun. But it's not because the axis flip-flopped. It's because the Earth went around the sun and is now in a new location that allows the North Pole to tilt away from the sun. In this location, the North Pole tilts towards the sun. So if the North Pole is tilted towards the sun is hitting the northern hemisphere more directly, giving it warmer temperatures. If the North Pole is tilted away from the sun, then the sun will be hitting the northern hemisphere more indirectly, giving it cooler temperatures. The opposite season is happening in the opposite hemisphere. So while we are having winter, the southern hemisphere is having summer. And while we are having summer, the southern hemisphere is having winter. In between, of course, we have our autumn and our spring. And in those particular instances, the North Pole is tilted out into space and neither towards nor away from the sun. We give each day that a season starts a special name. The summer solstice is when the sun is shining directly overhead at the northernmost point on the northern hemisphere. So it shines at 23.5 degrees north latitude, and that happens on June 21st. It gives us the most direct sunlight rays in the northern hemisphere, which gives us warmer temperatures, and we also end up with longer days. So here's an example of the summer solstice for the northern hemisphere. The sun's rays are striking most directly 90 degrees right here in the northern hemisphere at the Tropic of Cancer, and more indirectly down here in the southern hemisphere, giving it cooler temperatures. You'll also notice that the day-night line is vertical to the sphere, whereas the axis is tilted. So that means that if you live anywhere in this latitude, your daylight hours are much longer than your nighttime hours. And indeed, if you live above the northern Arctic Circle, you never see the sun set for a number of days in the summer, because as you move around the axis in this circular manner, you never reach the part of the sphere that has nighttime. The opposite is happening in the southern hemisphere. The sun does not rise for a number of days during their winter, our summer. The winter solstice is the same concept, it's just the other direction. So in this case, the tilt is directly away from the sun. It's December 21st. We get very indirect rays of light, which gives us cooler temperatures. We also have shorter days. So same Earth, tilted in the same direction, except we've moved around the sun. Now the sunlight is coming in from the right side. You can see it hits most directly in the southern hemisphere, very indirectly in the northern hemisphere. And we have much longer days in the north. Much longer nights in the north and much shorter days, whereas the southern hemisphere gets long days and short nights. The vernal equinox is where the axis is, again, tilted in the same direction, but it's in such a place where it's tilted out into space, not towards or away from the sun. The sun shines directly overhead right at the equator, and day and night are equal lengths, 12 hours of daylight, 12 hours of darkness. Equinox, same first three letters, that's how you can remember it. The vernal or spring equinox happens on March 21st, and the autumnal or fall equinox happens on September 23rd. This just shows you daylight hours and latitude and the month of the year. You don't need to copy this. This is just for interest.